Well, hey everyone, and guess what? It's time for another lovely episode. Today we're going to be talking about how we can add and subtract, right? So the sums and the differences of fractions, but we're actually going to, of fractions, that's going to fall off the screen. Here, S, fractions. That's nice and organized. We're actually going to talk about like what we've already learned and know so far, and then take that to like, what are these next steps? So what I mean by that is like one thing we have learned for sure is this idea of how we can add fractions when they are the same, right? When they have those denominators that are the same. So if I had 3/4 and I'm going to add 2/4, let's say, for an example, right? We've learned that really this isn't about the denominator, because the denominator only just shows us what we took something and how many pieces we cut it into. So if I thought about, again, this model, I cut these into 4 pieces each, and this is 3 of them, and this is 2 of them. And if we, added there, if we added those together, right, then what that would get us is we would have one, that's not going to show, we'd have 1, 2, 3, 4, 5 pieces. So 1, 2, 3, 4, that's not enough. So we've learned, let's make another model, 5, which would get us 5 out of 4, which again, we've seen up here, this whole simple trick, right? When my denominators are the same, then I'm working with the same size pieces, so I can just add them together. Like that's how it works. When my pieces are the same size, I can just add them together. So anytime our denominators are the same, like 1/8 plus 3/8, right? My denominator stays, just slides on over, and then I add my numerators, and that's what I get. I get 4 out of 8, which is true because I have 4. Now I have 4 slices of the 8. First I had 1 slice, then I had 3 slices, and together that is 4 of the 8 slices. That's been great. We've done this. Now, what is starting to happen that we'll notice is that we might start to get something where our denominators are no longer the same. And what we've learned is we were like, oh, wait, though, this is kind of cool because in the past, I've just been able to say, oh, well, what are my, if my denominator is the same, I just slide it over and then I add my numerator, but these aren't the same, so I can't just slide them over. So this is what we refer to the idea of like what we do when we have unlike denominators, right? We have denominators that are not the same. Now we can still add these together and we can subtract them as well. We just can't do it in the way that we've looked at it before. So let's kind of play with this. So I'm going to move over to this one and we have 3/4 and we're going to add 1/8. So let's go back to this idea. Now, what can definitely help me is I want to think about how one could model this, right? So I'm going to start here with a cool model. And I'm going to cut it into 4 pieces. All right. And then I could shade in 3 of them. So 1, 2, 3. And then I would actually model this other one as well. But the problem is at this point, my pieces are not the same size, but okay, whatever. So let's see, I'm going to cut this first into 4, and then I'll cut it into 8s. And then we could shade in one of them. So make sure we do that. Okay, there. Okay, so there is like kind of where we're at with this. And we've noticed that if our pieces are the same size, we can just count how many we have and add them together. But as you can see here, my pieces are no longer the same size. So that brings us to when we're doing this type of work, what our very first step would be to adding fractions that have unlike denominators or subtracting, right? Rules are the same. is that we always got to make sure that our denominator, wow, oh boy, let's try that again. Denominator, that our denominator is the same. That's always the first. If they're the same, great. Slide it over and then add the numerators. But if they're not, what we have to do is we have to make them the same. And how we do that is something we already know. It's the concept of taking and doing equivalent fractions. Because if I make an equivalent fraction, then I can actually make these the same. And so that's what I'm going to do. I notice when I look at this model that this is cut into 8 pieces. Sorry, I'm just trying to go over those lines a little bit better. It's kind of sloppy. And this is cut into 4, but notice I kind of have this gift that like these lines are lined up. And this is where, again, like 4 and 8, they're friendly denominators. Because all I could do here is if I took this and cut each one of these in half, I've now made a new fraction. Now that fraction, I haven't changed its value, but I have cut it now into 8 pieces. And I now have 1, 2, 3, 4, 5, 6 of them shaded. So what I just did is I turned 3 out of 4 into 6 out of 8, but I didn't change its value. Remember, that's what equivalent means. But now that my pieces are the same, look what I can do. I'm just going to follow those rules, right? Now that they're the same, let's just follow our rules. Wow. Right, so now we're just going to slide and add. So my denominator is the same. I'm going to slide it over. Then 6 plus 1 equals 7. And that's what I get, 7 out of 8. So the truth is technically 3 out of 4 plus 1 out of 8 when I'm done is 7/8. And the reason I was able to do that is, again, I checked, is my denominator the same? And it wasn't. So I made an equivalent fraction, which I did over here. And then I just did my slide and add rule because I changed it so my denominators were the same. Of course, we're going to try some more, so don't worry. So let's just keep those steps in mind, and let's go ahead and try some more. So again, I'm going to write that in. So wow, I don't know. My brain is not working right now. Again, denominator, same. All right, and then if not, let's get equivalent. And then slide and add. So let's go ahead and take another example here. And let's take 2/5 and add that to, let's say 3/10. Okay, so step 1, are my denominators the same? And as we can see, they are not. They're not. All right, one of them is a 5 and the other one is a 10. Those are not the same numbers. So what I'm going to do is I'm going to model these out so I can think about which one I could change to become equivalent. So remember with the model, and I would always recommend make them nice and big. Give yourself space. Do it on a piece of paper. Give yourself plenty of space so that things don't get crowded and confusing. Make sure they are the same size to the best of your ability. And now I'm going to cut this one into 5 pieces. So the trick with 5 is you actually just draw 4 lines and you try to make them equal, which that actually looks really good. I like that. So I have 1, 2, 3, 4, 5. And then if I think about that relationship in numbers, right? Oh, maybe I should shade. Sorry, my fault. Let's go ahead and shade that in. So I need 2 of them. So 1, 2. Okay. Now, if I think about this relationship here, which is great, is I see a little gift because I'm actually going to copy this fraction exactly the same. And it won't always happen this way, but it worked out pretty good for me. And I can take and turn this into tens. So I'm going to cut each one in half. And that would give me 10 because that's, again, half and doubling, right? It's just an understanding of that. And then I'm going to shade in 3 of them. So 1, 2, 3. Okay. So now I got to look at this and think to myself, like, what's going to be an easier process for me, right? What's going to work better for me? Do I want to take this one and chop it up so I get 10 pieces? Or do I want to take this one and try to erase and make them 5 pieces? And I got to say, trying to erase would be really weird and difficult. So it actually really does work well for me to say, oh, well, let's take this one and let's cut it into 10 pieces. That way, both my fractions will actually be out of 10. And now if I count that, I have 1, 2, 3, 4. This is 4 shaded pieces out of 10. So what I did here is I just made this fraction 4 out of 10. I did an equivalent fraction of 4 out of 10. I don't like how sloppy that looks. Let's fix that. So, let's try that again. 4 out of 10. And then this one is still 3 out of 10. So then if we just add those together, we're going to get 7 out of 10 because there's our trick, slide and add. And that's true if we go back and look at our model, right? It's true if we go back and look at our model. I have, let's try that again. I don't know, man, okay, 1, 2, 3, 4, 5, 6, 7 pieces. And again, I did so all by creating an equivalent fraction, and then I followed my rules. So remember, this is how this can work. First step, are my denominators the same? If they are, slide and add. That works. But if they're not, then make an equivalent fraction so they are both cut in the same types of pieces. I would do that by modeling. Then once your denominators are the same and you have your new fraction, right? Like in this case, 2/5 and 4/10, they are equivalent, same value, different look. Then I can just follow the rules of slide and add. So go ahead and give that a go. See how that works. Remember to always be asking questions, right? This is just a quick preview. We'll be talking more in class to really push your thinking, but always ask questions so that this does make more sense. And as always, thank you for your wonderful work, and we'll see you soon.